Right, so now we're going to do a bit of nomenclature. And nomenclature is how we name things. That's what nomenclature means. The first thing we're going to start with is binary molecular compounds. So molecular, binary means two different elements. Molecular means they're covalently bonded together. And compounds means that they are, in this case, two different elements. So when we're dealing with binary molecular compounds, when we try to figure out a formula, it's different than when we're doing it for ionic compounds. Ionic compounds are made of ions and they have charges. And when we come up with a formula for the compound, we come up with the lowest ratio of cation to anion that gives us a neutral compound. And we can do that by determining, by the charges of each ion. In molecular compounds, we're basically bonding nonmetals to nonmetals, or nonmetals to metalloids, or metalloids to metalloids, and they're not ions. So there's no way we can tell how many of each we need unless the name actually tells us that. Right, and to do that, we use prefixes. And in this case, we use the Greek prefixes. And I'm going to go through them now. And I'll go from 1 to 10. There are obviously ones greater than 10, but we'll just deal with the first 10. All right, so mono means 1. Di means 2. Tri is 3. Tetra is 4. Penta is 5. Hexa is 6. Hepta is 7. Octa is 8. Nona is 9. And deca is 10. So we're going to use these prefixes with the elemental names to determine the name of a binary molecular compound. A compound that's made of two different elements, either nonmetals or metalloids. All right, so to name these things, we use the prefix plus the element for the first element listed. So that's the first one. And then we're going to do the prefix plus the element base name and we're going to end the second one with IDE. Okay, this is for the second element listed. Okay, so a couple rules that we're going to deal with here. Okay, so I'm going to do two examples because they give us both of our situations where there are slight exceptions. Okay, so CO and CO2. Right, we know CO2 is carbon dioxide. All right, so carbon dioxide. You can see that there's no prefix in front of the carbon. So if the first element, if there's only one of the first element, we don't use the mono for the first element listed. Okay, in this case we have carbon listed first and oxygen second. Since there's only one of the carbon, we don't write monocarbon dioxide. Okay, so if we have one of the first element, the mono's dropped. That's not true for the second element. We use mono for the second element. Only the first element we drop the mono. Right? The other thing is the CO, and that's carbon monoxide. Okay, so we can see again there's only one carbon, so we drop the mono from the first element, in this case carbon. However, we use it for the second element, mono. All right. One thing to notice about that, our second thing here. So the prefix is mono, and the element is oxygen. so we use oxide. So ox is the base part of oxygen. So we just put oxide in there because we have to end the second element in IDE. But notice, if I was to put this together, it would be MONOOXIDE. So it would be monoxide with the OO in the middle of it. If we have oxygen as our second element or our first element, and the prefix ends in O or A, we drop that letter. So in this case, our prefix ended in O, so we drop that O and only use the O from oxide. So monoxide. If, for example, we had 5 oxygens, it would be pentoxide with the A being dropped. So if we have oxygen and a prefix that ends in O or A, we drop the O or A from the prefix and just keep the O from the oxygen. Okay, and those are our 2 exceptions. The one exception is we do not use mono for the first element if there's only one of them, and if oxygen is one of the elements and the prefix that goes on the oxygen is an O, or that ends the and the prefix and the letter that ends the prefix is an O or A, we drop that O or A and just keep the O from the oxygen. If it's an I, like di or tri, we keep it, right? Dioxide. It's just the O or A together with the O in front of the oxide or oxygen. Just gives us a weird vowel combination that sounds weird if we say it. So there's our way we name them. Let's do a couple of examples. So what would, if I give you P4S2, what would you name it? Well, the first thing to notice is they're both nonmetals. So they're covalently bonded together, so we have a molecule. So we're going to name it just like we learned in this. They're not ions, right? Because our ions have to be kind of a metal or a positive ion and a negative ion. But this is 2 nonmetals. So the electronegativity between the 2 isn't that much different. So this is definitely covalently bonded together. So tell me how many of the element there are using the prefix. So 4 is tetra. And that's phosphorus. So tetraphosphorus. And then there's 2 sulfurs. So disulfide. So tetraphosphorus disulfide. P4S2. So if you get the name, it's pretty easy, right? Because it tells you how many of each and which element there is. So what about SCl4? Okay, we're naming these. So that's sulfur, and there's only one of them, but we don't put mono in front of the first element. So sulfur, and 4 is tetra, and that's chlorine, so it would be tetrachloride. Okay, so you can see the first element, we don't change the name of the element. We would only put a prefix on it, but because there's only one of them, we don't do that for that. There's our prefix. We end the second element with IDE, and the middle is the element's base name. So what if we go the other way? So what if we have, I'm trying to see if I can, xenon hexafluoride. Okay, so these are not proper names, so they're still lowercase. So xenon, there's no prefix in front of it, so that must mean I only have one of them. Hexa means 6, and fluoride is fluorine. XCF6. So your first thing is like, well, xenon's a noble gas. It shouldn't react. Yeah, the larger ones will with the more electronegative non-metals. So fluorine's a pretty common one. Krypton will also react with fluorine. So we will see some of the larger, well, pretty much krypton and xenon, the larger noble gases react a little bit, and usually with fluorine or chlorine, the higher electronegative nonmetals. Right? That's it for binary molecular compounds. So a compound that contains two nonmetals, nonmetal and a metalloid, or two metalloids, this is how we name them.